Hey guys, welcome back. Day 21. We're going to talk about the types of bonding. First, let's define a chemical bond. Chemical bond. So the chemical bond would be the sharing or transfer of, in our case, valence, but electrons to attain stable electron configurations. Two types that we're going to talk about in this course: ionic and covalent or molecular bonding. Ionic, metal, and a nonmetal. Also, polyatomic ions are in there with a metal. We're, of course, on opposite sides of the periodic table. And the difference here is that basically it's ended. It's not infinite, but we're going to say an infinite array of alternating cations and anions. So this is a plus, minus in 3D, right? It's three dimensionals. So it's a cation, anion, positive, negative, all the way to the end of the sample. And, the size of particles now are tiny, so even a little piece of salt, a little grain of salt, there's trillions of ions in there. And so it seems like almost an infinite lattice. This is contrasted with covalent bonding, which is two or more nonmetals. Above the stairs, and of course hydrogen, because hydrogen is above the stairs. Now the major difference here is that this is covalent bonding makes molecules, and they're small, discrete units. So when we come to representing these atoms in these types of bonds, we're going to use Lewis symbols. And you can probably guess who came up with these symbols. These represent the valence electrons of main group elements. And the main group elements, of course, are the tall elements. And we represent these valence electrons of the main group elements as dots around the element symbol. So what does that look like? Now, SOP, standard operating procedure, we would go 1, then 2, then 3, then 4, 5, 6, 7, 8. Does it have to be that way? No. So let's do some examples. H, HE, then we'll do LI, BE, B, C, N, O, F, NE. We'll do all of those. So hydrogen, 1 dot. So this. Helium, 2 dots. Now, no, most of the time helium will be HE, and you'll see it this way. 2 dots on one side, right? Because it's 1s2, full, valence shell, stable, full orbital. Lithium, 1 dot. Beryllium, 2 dots. Note sometimes you'll see the beryllium dot, opposite sides, and that's okay too. Boron, 3 dots. Carbon has 4 dots. Nitrogen has 5 dots. And a lot of times with nitrogen, you'll see both on top. You don't have to. Oxygen, 6 dots. And a lot of times you'll see this with oxygen too. So even though I'm not going in the 1, 2, 3, 4, 5, 6, 7, 8 order we did up here, that works. It doesn't matter. You can have the dots paired down here on the bottom and the left. It does not matter. You just kind of have 2 dots on each side. Then we got fluorine. And finally, neon. So those are our dots. So group, if we look at the groups here, group 1, group 2, group 13, 14, 15, 16, 17, and 18. They're all going to look like, the top of the group. So sodium will have 1 dot. Potassium has 1 dot, right? Because potassium has 1 valence electron, just like sodium and lithium. Carbon has 4 dots, so does silicon. Oxygen has 6 dots, so does sulfur and selenium and tellurium. Right? These are the valence electrons. So that's the Lewis symbols for the main group elements.